Can you solve this algebra challenge? Here's the question. Given this number, 8th root of 2207 minus 1 over 2207 minus 1 over 2207 minus until infinity. Now, suppose this number is equivalent to a plus b times square root of c all over d, then the question is, what is the value of a, b, c, and d? Pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. By the way, this question is suggested to us by one of our followers, and he said that this question comes from PUTNAM. Alright, so here's the solution. Now, of course, let's get this expression, because this expression, we suppose that this expression is a real number, and this number, what we're going to do is to let this be equal to a variable, and let's call this as x. Now, what do we know about x? Since this number is inside the 8th root, we suppose that this number is greater than 0. Now, another observation is this number, or this x, is greater than 8th root of 2207 if we remove this piece, right? And also, this number is greater than 8th root of 256. Now, why do we need this 256? Because this 256 is the closest number that we have an 8th root to 2207, because the 8th root of 256 simply equal to 2. Therefore, this x, or this 8th root of 2207, is greater than 2. So we can say that x is greater than 2. Alright, so we will use this condition later on. So let's set aside this condition. Now let's proceed to solve for the value of x. Now what we're going to do is to raise both sides to 8. So we have x raised to the power of 8 equals 2207 minus 1 over 2207 minus 1 over 2207 until infinity. Now let's focus on this result. Now, as you can see, this expression on the bottom of 1 is exactly this x raised to the power of 8. So we can replace this with x raised to the power of 8 like this. And now let's multiply both sides by x raised to the power of 8. And what we're going to do is to equate this to 0. Now we have this equation, x raised to the power of 16 minus 2207 x raised to the power of 8 plus 1. Now let's focus on this result. Now what we're going to do here is we try to factor this equation consisting of x raised to the power of 16. Now one way to factor this out is using this technique. Now suppose this expression right over here can be factored in this format: x raised to the power of 8 plus p x raised to the power plus 1 multiplied by x raised to the power of 8 minus p x raised to the power of 4 plus 1. Because using the construction of this expression, if we multiply x raised to the power of 8 to x raised to the power of 8, we have here x raised to the power of 16. And 1 times 1, this will give us 1. So now, what will happen if we multiply these two factors? So let's get these factors, then multiply them. If we do that, we get something like x raised to the power of 16 minus p x raised to the power of 12 plus x raised to the power of 8. So x raised to the power of 8 multiplied to these three terms. Next, we have p x raised to the fourth power multiplied to these three terms also. So we have p x raised to the power of 12 minus p squared x raised to the power of 8 plus p x raised to the fourth power. And the last one, multiply this one to these three terms. So we have x raised to the power of 8 minus p x raised to the power of 4 plus 1. Now, as you can see, a lot of terms cancel out, like this one, negative px raised to the power of 12 and positive px raised to the power of 12. Another is positive px raised to the fourth power and negative px raised to the fourth power. So what's left is x raised to the power of 16 plus x raised to the power of 8 minus p squared x raised to the power of 8 plus x raised to the power of 8 plus 1. Now, combining like terms, so we have 2x raised to the power of 8 and factor out x raised to the power of 8. So we have x raised to the power of 16 plus x raised to the power of 8 multiplied by this factor 2 minus p squared plus 1. So as you can see, if we multiply these two factors, this is somewhat related to this expression. So to find the value of this variable p, what we're going to do is to equate 2 minus p squared to the coefficient of x raised to the power of 8, which is negative 2,207. Now, let's solve for the value of p. First, subtract 2 on both sides. Multiply both sides by negative 1. Get the square root on both sides because 2,209 is a perfect square. And if we get the square root, we have 47. Therefore, the factored form x raised to the power of 16 minus 2,207 x raised to the power of 8 plus 1 simply equal to x raised to the power of 8 plus 47 x raised to the fourth power plus 1 multiplied by x raised to the power of 8 minus 47 x raised to the power of 4 plus 1. Now let's focus on this factored form, and notice in the first factor we don't get any real solution. Now the reason is if we plug in any real number x, this number or this value is always above the x-axis. So it doesn't cross the x-axis, therefore we don't have any real solution. Therefore, the value that we need comes from this expression, x raised to the power of 8 minus 47 x raised to the fourth power plus 1. And as you can see, what we're going to do is to use the same method as before. So assume that this expression can be factored as x raised to the fourth power plus qx squared plus 1 multiplied by x raised to the fourth power minus qx squared plus 1. So to factor this out, or to find the value of q, what we're going to do is to equate 2 minus q squared to negative 47. And let's solve for the value of q. Subtract 2 on both sides, multiply both sides by negative 1, and then get the square root on both sides, so q equals 7. Therefore, this expression, we can factor this out nicely as follows. X raised to the fourth power plus 7x squared plus 1 multiplied by x raised to the fourth power minus 7x squared plus 1. So let's replace this with its factored form. Now, this second factor, using the same reason, we don't have any real solution for this kind of factor because the value is always above the x-axis. So the value that we need lies in this factor. And now, of course, to factor this out, what we're going to do is to use again this concept. So let's reduce the exponent. Now, to find the value of r, let's equate 2 minus r squared to negative 7. Solve for the value of r. Subtract 2 on both sides. Multiply both sides by negative 1. Get the square root on both sides. So r equals 3. So we can say that we can factor this out, or the factored form of this expression simply equal to x squared plus 3x plus 1 multiplied by x squared minus 3x plus 1. So now, let's get this factored form. And now, let's check the roots of this factor x squared plus 3x plus 1. Now, using the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. Now, using the quadratic formula, we get negative 3 plus or minus square root of 9 minus 4 simply equal to 5 all over 2. Now, as you can see, the value of x is always less than 0 or a negative number because negative 3 plus square root of 5, square root of 5 is 2 point something. So, negative 3 plus 2 point something is negative number. And negative minus square root of 5 all over 2 is technically a negative number. Therefore, the roots in this quadratic equation is always less than 0. So we can say that we don't have any positive roots in this factor. Take note, we have here a number that is greater than 2. So we don't want a negative number. Therefore, the only last factor that left is x squared minus 3x plus 1. So let's check these roots using the quadratic formula. We have 3 plus or minus square root of 9 minus 4 all over 2, which is, when we simplify this, 9 minus 4 is 5. Now this number is greater than 0 or a positive number. Now, let's focus on this result. Now, we found two possible values for x. We have x equals 3 plus square root of 5 over 2 or 3 minus square root of 5 over 2. Now, which one is correct? Now, the last condition that we need is this condition, wherein we know that x is greater than 2. Now, this number, 3 minus square root of 5 over 2, the square root of 5 is 2 point something, so 3 minus 2 point something is about 0 point something over 2. So, technically speaking, this number is less than 2, or simply less than 1. Therefore, the value that we need is this number, 3 plus square root of 5 over 2. It follows that A equals 3, B equals 1, this number, C equals 5, and D equals 2. And this is our answer to this question. Therefore, given this 8th root of 2,207 minus 1 over 2,207 minus 1 over 2,207 minus until infinity, then the numerical value of this is 3 plus square root of 5 over 2. And the values of A, B, C, and D are 3, 1, 5, and 2, respectively. And as always, we are done.